We're counting down the 9 most unstoppable machines built to conquer the frozen extremes. From ingenious tracked haulers once relied on by oil crews, to colossal military behemoths and record-shattering mining giants, each vehicle on this list earned its rank by surviving what would destroy lesser designs. Some twist, float, or plow through snow in ways you would never expect. Which engineering marvel takes the ultimate Arctic crown? Join the expedition, subscribe now, and let us begin with number 9. In the Canadian North, oil crews faced a problem no ordinary truck could solve. Endless stretches of muskeg and snow swallowed tires whole. Enter the Nodwell 110, a bright orange dual-tracked carrier built in the 1960s by Bruce Nodwell. Its wide twin tracks spread 11 tons of payload over soft ground, letting it glide where wheels would sink and vanish. A Detroit diesel 6553 engine pushed nearly 200 horsepower through planetary drives, while the low-profile undercarriage kept ruts to a minimum. Field operators recall the satisfaction of crossing bogs with barely a mark left behind. The Nodwell 110 set the standard for Arctic workhorses. It proved that in the frozen wilds, flotation beats brute force every time. When a Soyuz capsule came down in the middle of a frozen marsh or a half-flooded steppe, the Soviets sent in the ZIL-4906, codenamed Bluebird. This 6-wheeled amphibian was built for one job: to reach stranded cosmonauts wherever they landed, no matter the terrain. Bluebird could push through snowdrifts at highway speeds, then roll straight into a lake and float paddling along at up to 9 kilometers per hour. On its rear deck, it carried a screw-propelled rescue craft, unloaded in minutes to tackle the last stretch across deep bog or tangled reeds. Fewer than 30 Bluebirds ever left the factory, yet everyone played a part in the high-stakes ballet of Soviet space recoveries, where the difference between life and death often came down to the right machine for the job. Across the Siberian lowlands, the Trom 20 rolls where even tracked giants hesitate. 4 balloon-like tires, each nearly as tall as a person, flatten under the vehicle's weight, spreading the load over a massive footprint. Typical tire pressures drop to just a few pounds per square inch, sometimes less than a tenth of what you would find in an ordinary truck. On deep snow and floating bog, the Trom 20 does not dig in. It hovers, cushioned by air, skimming over terrain that would swallow anything else. Engineers point out that these ultra-low pressure tires cut ground pressure by an order of magnitude, rivaling the best tracked machines. In the field, crews rely on this clever physics to ferry gear across endless marsh, proving that sometimes the softest touch is the key to survival in the Arctic wild. Hauling pipe and fuel across the Siberian tundra takes more than brute force, it takes ingenuity. The Ural 5920 answers that call with 4 independent crawler tracks, each one gripping the snow and muskeg like claws. Instead of a single set of treads, engineers split the load across 2 articulated bogies, each able to twist and pivot, keeping more than 30 tons of cargo balanced over ground that would swallow a truck whole. Under the hood, a massive V8 diesel engine, producing over 200 horsepower, sends power through a maze of differentials and transfer cases to all 4 crawler belts. Every kilometer of progress comes at a price. More tracks mean more moving parts, more wear, and a maintenance routine that never lets up. Field crews learned to respect the Ural's traction, but they also knew that keeping it running in the deep cold was a job for specialists. In the end, it was a machine that traded simplicity for sheer mobility, pushing deeper into the Arctic than any wheeled rig could dream. In the early 1960s, Soviet engineers set out to answer a question nobody else dared to ask. Could a wheeled machine, not a tracked one, master the Arctic? Their answer came in the form of the ZIL-167, a single massive prototype painted bright orange for visibility against the snow. Standing nearly as tall as a man, Each of its 6 wheels measured about 1.6 meters across and wore ultra-low pressure tires that let it float over powder and bog. Under the skin, 2 ZIL V8 engines, together pushing close to 370 horsepower, worked in tandem, each one driving a set of axles for redundancy in case one failed in the deep cold. The E-167 was not just a hauler, it was a rolling laboratory packed with instruments and technicians sent on trial runs across the Kola Peninsula and the Siberian tundra in 1963. Over thousands of kilometers, it climbed snowdrifts, forded icy rivers, and collected data on how big wheel designs coped with permafrost. In the end, the complexity and fuel thirst doomed it to museum status. But the lessons from this orange beast would echo through every Soviet Arctic truck that followed. High in the Carpathians or deep in a winter forest, the Tatra T-803 Kolos faced ground that broke lesser trucks. Its secret lay in a central backbone tube, a massive steel cylinder running the length of the chassis, shielding the drive shafts from snow, mud, and flying rocks. Each of the 8 wheels rode on an independent swing half-axle, letting the truck flex and twist over boulders or frozen ruts while keeping all tires pressed to the ground. This design gave the T-813 a kind of mechanical agility. Where a solid frame truck might snap or lose traction, the Tatra's flexible backbone absorbed the strain, and the wheels kept clawing forward. The air-cooled V12 diesel, rated around 260 horsepower, delivered steady power even in sub-zero starts. With nearly 600 millimeters of ground clearance and portal axles, the T-813 could straddle snowdrifts and ford icy streams, hauling artillery or bridge sections through places most vehicles would not dare. For armies and engineers working in the cold, this backbone chassis meant reliability was not just about brute force, it was about surviving the journey, no matter how rough the pass. Snow whips across a vast frozen plain as the MAZ-543 rumbles into view, an 8-wheeled colossus built not just for cargo, but for carrying the unthinkable. Developed by the Minsk automobile plant in the early 1960s, this machine was designed from the ground up to haul strategic payloads, from mobile missile launchers to radar stations, each demanding a platform that could survive the Soviet winter and deliver on command. Its most distinctive feature is the split cab design, 2 separate drivers' cabins flanking a central bay and leaving a clear channel for missiles or oversized equipment. This layout was not just for looks. It allowed the MAZ-543 to transport loads up to 22 tons, with the crew able to maintain and monitor systems during days-long deployments in sub-zero temperatures. Wide, tall tires and a central tire inflation system let drivers drop pressure to cross soft snow or mud, restoring grip where lesser trucks would bog down. In the blizzard, the MAZ-543's silhouette became a symbol of Soviet logistics, mobility for the heaviest weapons, even when the only road was a snow-choked track across the steppe. Across the Siberian expanse, the Vityaz DT-10 moves with a kind of mechanical grace that seems almost alive. 2 hulking tracked hulls, joined by a massive hydraulic hinge, twist and flex in perfect harmony as they cross drifts and broken ice. When the front unit climbs a ridge or dips into a hollow, the rear follows, the articulation joint yawing up to 40 degrees side to side, keeping both sets of tracks pressed flat against the snow. This is not just brute force, it is terrain-following intelligence, letting the 10-ton payload glide over powder, muskeg, or even thin river ice without bogging down or breaking through. Kinematic steering means the DT-10 pivots by bending its body, not by dragging tracks, so it can snake around obstacles that would stop a rigid machine cold. Amphibious tracks let it swim when the tundra floods, and in deep winter, operators trust the articulation to keep every ton afloat and moving. In the world of Arctic transport, nothing else fuses flotation and maneuverability at this scale. The DT-10 stands just one step below the realm of pure, unstoppable mass. The Arctic's final frontier is not a frozen river or a snowbound pass. It is a pit gouged deep into permafrost, where iron and oil lie buried beneath a crust of ice. Here, scale is everything. The Caterpillar 797F stands at the edge, dwarfing the men and machines around it. This is no ordinary truck. The 797F rises nearly 8 meters tall, with tires that alone weigh more than a family sedan. Its CAT C175-20 V20 engine produces over 4,000 horsepower, enough to move 400 tons of rock or ore in a single load, 4 times what a typical highway hauler could ever dream of. In the dead of winter, when the temperature plunges to -40 and steel snaps like twigs, the 797F keeps rolling. Arctic mines fit these giants with heated cabs, engine block warmers, and low-temperature hydraulic fluids, so crews can start their shifts before dawn and keep hauling through blizzards that would shut down most operations. Each round trip means climbing icy switchbacks, breaking down frozen grades, and dumping payloads into crushers that never sleep. Operators talk about the strange calm that settles in the cab, a cockpit perched high above the pit, insulated from the storm with the steady rumble of 20 cylinders shaking the world below. But the 797F is more than just muscle. In places like the Canadian oil sands or polar iron fields, one of these trucks can replace a whole convoy of smaller rigs, cutting costs and, in theory, reducing the chaos on icy haul roads. Yet every run burns hundreds of liters of diesel, and every pass leaves a mark on land that for thousands of years was shaped only by wind and caribou. For some, the 797F is the ultimate tool, proof that human engineering can master even the coldest, harshest ground. For others, it is a symbol of what is at stake when industry meets wilderness. In the Arctic, the biggest beast is not always the one with claws or fur. Sometimes it is a mountain of steel roaring across a frozen hell with a payload that rewrites the rules of survival. Across all 9 unstoppable machines, one pattern stands out. True Arctic survival demands relentless adaptation. From floating tires to monstrous engines, every breakthrough is shaped by the land's extremes. In the frozen north, only innovation endures. Which machine impressed you most? Let us know below and subscribe for more engineering legends.